Good evening, my dear JEE warriors, and just few days from now, you're going to have your physics board examination, and a lot of kids were requesting to conduct the classes, and here we are. And most of the students lose marks in case studies. Many students even don't know what exactly case studies are. Some students want additional practice. So that's why I'm here to give you an idea, to give you the most expected questions, to tell you how to work around with case studies. Do not be afraid of them, because at the end of the day, it is like a reading comprehension related to your syllabus. Some parts might look they are out of the syllabus, but you have to think at that moment what best can be done. Most of the information will be within the passage, but yes, you might have to use certain formulas, certain concepts from your syllabus as well. Don't expect everything will be there inside. Also, a little bit of common sense and option elimination also helps at times. Okay, so let's begin with the class. And hi, Ritesh, Arivarsu, Joker, Shrikant, Sanjit, Salat. Welcome, Apollo. Hi, Harish. Welcome, welcome, welcome. And don't be scared. And if you have got not so great results in your JEE Mains first attempt, do not keep that in your head, because now is not the time to think about JEE Mains. Okay, especially when board exams are 3 days, 2 days away. So after the physics exam is over, you will get a good gap for the chemistry. Then again, go back to your JEE preparation. Don't just prepare for boards. If your percentiles are decent enough, like above 85, 90 percentile, then prepare a little bit of JEE. And then 5 days or 4 days before the exam, start preparing exclusively for boards only. And that is going to help you keep the momentum of JEE. Else you will feel completely lost after the board exams are over. Okay, so let's begin with the class. I hope you have liked the video, shared the video, and subscribed to the Vedantu JEE English channel, guys. Yeah, done it. All right, so don't keep anything in your head now. Focus on case studies. Tomorrow I'm going to revise entire 12th standard book part 1 basically of 12th standard. Okay, it's going to be a marathon, and day after tomorrow we'll do part 2. I didn't want to take one session, because then the session might get diluted. So I kept two parts, part 1 for book 1 and book 2 part 2. Okay, so tomorrow and day after, right? Marathons for your 12th CBSE physics board exam. If you want these sessions, smash the like button, mark your attendance right away right now, and do not forget to subscribe, or else you are going to lose out on these critical informations, right? Okay. Hi, Rishwan. Thank you so much. Yes, your cap is here. All right. Let's focus. And here we go. By the way, a big congratulations to all those kids who made us really proud. 50 plus students who have scored about 99 percentile, and more than 210 students who have scored about 90 percentile. This is as for yesterday. Today night we'll get the updated slides, and 99.999 percentile by Ridesh, and who scored 100 out of 100 in physics. And there are many more kids who have done extremely well, and more students are going to follow as we count our results in the next couple of hours and days. So here is the first question. Let's read the passage, and based on this passage there will be some questions. There is a compound microscope. It's an optical instrument for observing highly magnified images of tiny objects. Magnifying power of a microscope is defined as the ratio of the angle subtended at the eye by the final image to the angle subtended by the eye by the object. When both the final image and the objects are situated at the least distance of distinct vision, it can be given that the total magnification is magnification of the eye lens into magnification by the objective lens. Consider a microscope. Focal length is given, eyepiece is given, separation is also given. Okay, based on that the questions are there. If you read this passage, it is very clear. It is nothing different from what you know from optical instruments ray optics chapter. Is that right? So it's the same thing. So some passages are exactly what you know in the syllabus. Some passages you will see now will be out of the syllabus, but related to the chapters and topics and concepts. Okay, so expect any kind of case study. Anything can happen. Now in these kind of passages you have to use your known formulas. The formulas except for this is not there in the passage. You have to recollect the formulas which are there inside your NCRT. Okay, optical instruments, microscope. Remember, there is a objective lens. In front of that, you put the object. The object makes an intermediate, real, inverted image in between the objective lens and the eyepiece lens. And that image is then magnified and virtual image is seen finally by the eyepiece lens. So there are two stages of magnification. First one is inverted and real. Second one is virtual, and again it is virtual, and it is erect with respect to the intermediate image, you can say. Okay, cool. So let's start seeing questions. The object distance for the eyepiece, so that the final image is formed at the least distance of distinct vision will be. So if you talk about the eyepiece lens, if you talk about the eyepiece lens, I want the image to be formed at the least distance of distinct vision. So image my image has to be formed at, let's say, 25 centimeters from it. The question is really, where is the object going to be? Where is the object going to be? So the object distance is under the question for the eyepiece. And the focal length of the eyepiece is already mentioned. The focal length of the eyepiece is 6.25 centimeter. The focal length of the eyepiece is 6.25 centimeters. Which formula will you use, my dear warriors? Come on, quickly let me know in the chat box. Yes, lens formula. Yeah, everybody start answering. Please increase the brightness. Just 1 second. Let me see if I can increase the brightness. Is it better, guys, now? I have increased the brightness. Just let me know if it is better. Yeah, is it better? Okay. So we are just going to use 1 by V plus 1 by U is equal to 1 by F. Yeah, everyone with me? Very good. Now what? Yes, lens formula for the eyepiece. Very good, very good. So V, what is V? It is the image distance and it is on the negative side, so minus 25. And then what else we have? Object distance, we do not know. And focal length is basically, it's a convex lens, so plus 6.25 centimeters. So take this on the other side, you will get 1 by U is equal to 1 by 6.25 plus 1 by 25. That's it. Solve this. You will get the value of 1 by U from this. From that, you will get the value of U. What is the answer that you are getting, guys? Yes, think about it. This is a lens, right? So not plus. Sorry, guys. Just made a mistake over here. 1 by V minus 1 by U. So sorry. Yeah. So I wanted 1 by U over here. So this will be minus 1 by U, you can think. So if you shift the minus sign on the other side, and then you will get the correct answer. Yeah. So what is the object distance that you are getting? Come on, let me know in the chat box. Let me know in the chat box right away, right now. Let me know in the chat box. Let me know quickly in the chat box. Yes. Come on, my dear warriors. 6.25. 6.25 is divisible by 25 if you think about it. Yeah, it is divisible by 25. You can take the common, LCM as 25. It goes 4 times if I'm not wrong. So this will become 4 plus 1. 4 plus 1 is 5. 5 by 125. 5 by 25 is nothing but 1 by 5. So U will be nothing but minus 5. So the answer should be 5 centimeters. Yes, perfectly correct. The correct answer is 5 centimeters. Okay. So the object which will make the final image will be 5 centimeters from the eyepiece lens. But remember that object is actually the image of the objective lens. It's an intermediate image. The intermediate image becomes the object for the next lens. I think the next question will be on that only. How far from the objective lens, how far from the objective lens should the object be placed so that you are able to see the image? Okay. Now, for the next scenario, here is the situation. See, this was the eyepiece lens. This is the objective lens. This is the objective. This is basically your eyepiece. We just saw that the object was 5 centimeters from the eyepiece. We just calculated it right over here, and this is your intermediate intermediate image, which becomes the object for the next lens. We just spoke about it. Now, if this is 5 centimeters, how far it is from the objective? Well, for that, the given data says the length of the tube, yes, is 15 centimeters. It is clearly mentioned, separated by a distance of 15 centimeters. So that means this distance, if it is 15 centimeters, if this distance is 15 centimeters from the objective, this intermediate image is going to be at a distance of 10 centimeters. Does that make sense, everyone? If this is 15, this is 5, obviously this will be 10 centimeters. So this intermediate image is formed by the main objective lens. So the actual object might be somewhere over here. The real object might be somewhere over here, and I do not know what is this object distance. Again, use the same formula. Yeah, all in one. What do you mean by that, Darshan? Exactly. Yeah. Again, use formula 1 by V minus 1 by U is equal to 1 by F, guys. Yeah. Image distance is going to be 10, not minus 10. It is on the right hand side. So this side will be positive, this side will be negative. Object distance, I do not know. Focal length, well, that should be given to me. Yes. The objective lens has a focal length of 2 centimeters. The focal length has a object the focal length of the objective is 2 centimeters. You can see it right over here. The objective lens focal length is 2 centimeters. That's it. So just put over here 2, positive 2. It's a convex lens. So 1 by minus u will be 1 by 2 minus 1 by 10. Well, so therefore minus 1 by u. LCM is basically 10, guys. 2 goes with 10 5 times. So 5 minus 1, which is basically 4 by 10, which is basically 2 by 5. So flipping it, so u will be minus 5 by 2. So this will be minus 2.5 centimeters. So 2.5 centimeters is right over here. So the final object where it is actually placed in front of the objective lens is at a distance of 2.5 centimeters. Yeah, I hope this is absolutely clear. Yes, very good, amazing. Many of you have given the right answer. Proud of you. Moving on to the next one. What is the magnifying power of the microscope in case of least distance of distinct vision? Magnifying power. Well, what is the formula of that magnifying power? It was clearly mentioned. It was the magnification of the objective lens multiplied by magnifying power of the eyepiece. Now, the magnification of the objective has the formula V by U, but this is image distance for objective, object distance for objective. Because it is least distance of distinct vision, remember magnifying power, just like your simple microscope or a magnifying glass, it has a formula of 1 plus D by Fe. Just this. You just take these two numbers and multiply, you will get the correct answer. Let's figure it out. What is the image distance for the objective? If you see, for the objective, the intermediate image is at a distance of 10. So just put 10 over here. What is the object distance? We just calculated. The object is at a distance of 2.5. Okay, so I'm just taking care of the magnitude. I'm not worrying about the sign. Into 1 plus least distance of distinct vision is 25. What is the focal length of the eyepiece? What is the focal length of the eyepiece? The focal length of the eyepiece, yes, focal length of the eyepiece, I think it was given right over here. Yeah, 6.25. It was nothing but 6.25 right over here, guys. Come on, do the math. 10 by 2.5, that is basically 4 multiplied by 1 plus 6.25 goes with 25. How many times? 4 times. 4 plus 1 is 5. 5 4s are 20. So the correct answer for this is 20. So remember, in microscopes, some numbers are written 20x, 30x, 40x. So 40 times, 20 times. So that is this number. 20 is the right answer. Yeah, very good. Amazing, 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 amazing. Very good, guys. Many of you have got the right answer to this question. Moving on to the next one. The intermediate image formed by the objective is what? I just mentioned this sometime back, but still, in case you are not listening, so your real actual object is somewhere over here. You will get an intermediate image. This is your intermediate image. As you can see, it is inverted. It is also real, and yes, it is magnified. Yes, so real, inverted, and magnified, which is nothing but your option number A. That is the right answer. You can see it is inverted, it is real, and yes, it is going to be magnified. Option A. Very good. The magnifying power of a microscope increases with which of the following statements? Come on, answer it correctly. Very good. Gungun, Kavin, Mesim, Harish, Curiosity, Salatim. Awesome. Sir, what if you use L by F naught? See, that is an approximation EAD2. That formula which you are saying is only valid when the object is placed at the focal length of the objective and the image is formed very close to the eyepiece. Only then that formula is applicable. That is an approximate formula. Okay. Okay, perfect. So let's see how many of you can get the correct answer for this particular question, my dear warriors. Many of you are saying option D, focal length of both objective and eyepiece are released. So the magnifying power, the approx formula is basically what? It is the length of the tube divided by objective focal length multiplied by 1 plus D by Fe. This is the formula. Now, if you want to increase the magnifying power, length of the tube has to be increased or focal length has to be reduced. And even this focal length, if it is reduced, then the ratio will increase. Denominator reduces, the ratio increases. So the focal length of the objective and the eyepiece both have to be decreased so that the ratio will increase and the magnifying power will increase. So option D is absolutely the right answer. Many of you gave it correct. Very good, editor Naga, Salatem, Praveen. Yes, awesome, 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 Ritish, awesome. No, Mutuku, it is not option B. Yes, Gugun, that is option number D. Perfect. Moving on to the next question. This is the next paragraph. Read it carefully. Read it carefully. Electromagnetic radiation is natural phenomena found in almost all areas of daily life, from radio waves to sunlight to X-rays. Laser radiation, like all light, is also a form of electromagnetic radiation. Electromagnetic radiation that has a wavelength between this and this is visible to the human eye, is commonly referred to as light. At wavelengths longer than 780, optical radiation is IR, infrared, which is not visible. At wavelengths shorter than 380, the radiation is ultraviolet, it is also not visible to the naked eye. The term laser light refers to much broader range of electromagnetic spectrum than just visible spectrum, anything between 150 nanometer to 11,000 nanometers, that is right from ultraviolet to far infrared region. The term laser is acronym which stands for light amplification by stimulated emission of radiation. Now, as you can see, this is a passage which is a mix of the syllabus of electromagnetic waves and also out of syllabus. So expect such things. They might try to scare you by putting such complex terms and you'll be like, sir, I don't know anything about laser. Sir, I've heard about laser, sir. Sir, when I was walking, no, sir, in the street, I was using that green torchlight laser and I was putting on people's eyes and I was making fun of cat, sir. The cat was running and chasing the laser. Only that much I know about the laser, sir. I don't know anything. Don't worry. Even if you have troubled the cats, the ghost of the cat will not come and haunt you because it is actually a simple passage only. Okay. So let's see. Einstein explained. See how they try to scare poor kids. We are poor kids. Okay, we are scared. We just played around with lasers and cats. That's all. Einstein and all that, man, don't worry. Einstein is chilling only over here. Okay, Einstein explained the stimulated emission. In an atom, electron moves to higher energy level by absorbing a photon. Electron goes by absorbing a photon to a higher energy level. Correct. When the electron comes back to lower energy level, yeah, what it did? It absorbed the photon. It ate a photon and it went up. But when it comes back, it will spit out that photon. Okay. So imagine you eating a photon. You are an electron. You went up higher energy level. You came back. You spat out the photon. Okay. So same thing. So when the electron comes back to the lower energy level, it does it gives that photon. Okay. This is called spontaneous emission. It's as if you ate some chocolate which you don't like, some very horrible, very terrible chocolate or lollipop you ate. You got excited and then immediately got de-excited and you spat it out. That is spontaneous emission. Spontaneous emission. Okay. This may also happen that the excited electron absorbs another photon, releases two photons and returns to the lower energy state. This is known as stimulated emission. Meaning, imagine you ate one chocolate, okay, lollipop, something you ate. You got very excited. You get very excited. But then you bit it. You bit it. Two parts have happened. Two parts. And you did two photons came. That is what has happened over here. So the electron got excited, and when it gets de-excited, in that de-excitation process, one photon came, another photon came in the transition. So there were two transitions which are happening. That is called as stimulated emission. Is that right? Laser emission is therefore a light emission, whose energy is used in uh, lithotripsy for targeting and ablating the stone inside a human body organ. See, complex terms are used. Don't get scared. Sir, what is this? Neat stuff, medical stuff. Apart from medical usage, laser is used for optical display, printer, barcode, and reader. Okay. So, great passage. Let's see whether we can solve the questions. What is the full form? Look at it, man. I mean, like, take this on your face. Really. They are asking full form of laser after such a big passage. Full form of laser. Light amplification by stimulated emission, if I'm not wrong, somewhere it was there. Light amplification by stimulated emission of radiation. There you go, man. That's it. Option B is the right answer. Everybody? Yeah? Amazing, 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 amazing. Yeah, very good, very good. Many of you have given the right answer. Moving on to the next question on your screen. The stimulated emission is the process of light of a photon when electron comes back from higher to lower, release of two photons by absorbing one photon when electron comes back to higher to lower energy, absorption of a photon when electron moves from lower to higher energy. None of the above. Guys, this is simple. The stimulated emission, which one it is? Yes, very good. B option. Yeah, remember, stimulated emission means you took one lollipop and you did two times, because you broke that photon into two parts and you spat it out two times. That is stimulated emission. Okay, absorbing one photon and coming back by releasing two photons. Perfect. What is the range of amplitude of the laser? What is the range of laser? Actually, not the amplitude, it's the range of the wavelength, not amplitude. It should be wavelength. Yeah, I think I just mentioned it sometime back over here, or rather it is there in the passage. Just have to look at the data. 150 nanometer to 11,000 nanometers, guys. So that should be the answer. 150 to 11,000 nanometers. Yes, both of the above. 150 to 400, 700 to 11,000. Yes, both are in the range. So it's slightly tricky question. It is not very direct. Many people will be like, sir, 150 to 400 is only a part of the range. Sir, 700 to 11,000 is also part of the range. So look at option C. It says both of the above. So both are a part of the range. Got it, everyone? All right. Let's move to the next one. Lithotripsy is what? Industrial, medical, laboratory process control. It is a medical application to detect stones in the kidney. So they use that laser light to figure out if there are any stones in your kidney. Okay. So it's a medical application. It's a laser for used for targeting and abating the stone inside the human body. Okay, so it dissolves it, it somehow cures it. We don't have to worry about how it cures and all that. So for detecting and curing the person. Laser is also used in optical radio ionization, optical disk drive. I think it was there in the passage. If you see, that is what you should read the passage carefully. Optical disk drive, printer, barcode, reader. Satellite was not mentioned, radio waves, nothing was mentioned like that. So yes, definitely it is optical disk drive. Option A is the right answer. Very good. Let's go to the question number 3, guys. Ready for it? Yeah, I'm making the most expected questions for all the chapters tomorrow, man. Tomorrow, full-fledged revision is coming. Full-fledged revision of your entire 12th syllabus, part 1 and part 2. Okay, so get ready for it. Here is the first question. When an insulator is placed in an external field, dipoles become aligned, induced surfaces charged, insulator established a polarizing field EI in its interior. The net field is the insulator, is the vector sum of E and EI as shown in the diagram. On the application of external field, the effect of alignment of the electric dipoles in the insulator is called polarization and the field E. This is a direct passage from NCERT, guys. And EI is called as the polarizing field. Okay, this should be EI. I think that is not printed properly. EI is known as the polarizing field. The dipole moment per unit volume is known as the polarization P, and the polarization is susceptibility into the net electric field. So what happens is, if you have a dielectric medium and you apply external field, inside materials become polarized, or the polarization gets reoriented and it opposes the external field. So the net electric field inside the material is the combination of external field plus the opposing field. So if you take the total dipole moment of the polarized material per unit volume, that is called polarization, and that if you divide it by the net electric field, that value, that ratio is called susceptibility of the dielectric medium. Okay, so that is what is mentioned. Which of the following is an example of polar molecule? Come on, guys. Oxygen, two same atoms, they will pull electron clouds equally, so no net dipole moment. Hydrogen, one single fellow papa, what will you expect? Nothing. N2 is like O2 only. It cannot create a unbalance of charges. HCl, hydrogen chloride, definitely. Chlorine will become negative, hydrogen will become positive. Yeah, correct. So, and therefore you will see that's a polar molecule. Got it? Yeah. CO2, what if CO2 would have, come on guys, answer it in the chat box. What about carbon dioxide? CO2, sir, oxygen will pull from carbon, sir, so it will become polar. Is it so? CO2 is a special molecule, it's a linear molecule. So linear molecule, what will happen? The net dipole moment will cancel out. Net dipole moment will cancel out. Isn't that right? Yeah, but H2O, it will be a polar molecule because the dipole moments are at an angle and they produce a net vector dipole moment. Correct. When air is replaced by dielectric medium of constant K, the force of attraction between the charges separated by distance increases, remains unchanged, decreases, or increases. Well. The force formula is given by what, guys? It is 1 by 4 pi epsilon naught into dielectric constant Q1, Q2 divided by R square. Can you see, if K comes over here in the denominator, the force will reduce? So it has to reduce, guys, because K is in the denominator. So it decreases K times. That is the correct answer. Option number C. Option number C is the right answer. Very good, very good, very good, very good. Excellent. Let's move to the next question on your screen. Which of the following is a dielectric? Copper, glass, antimony, none of these. Nice question, because many kids will get confused between antimony and glass, or even none of these. Copper is a conductor, so out of question. Antimony and glass, what do you think? Antimony is actually a semiconductor, if you remember, and glass is an insulator, and all these insulators, polar molecules, definitely, yeah, it is going to be glass only. Yes, it is a dielectric. Conductor, semiconductor, dielectric, insulator. So basically, insulators, whatever you see, will be dielectric. Okay, is that understood? Antimony, silicon, germanium, these are all semiconductor devices from the last chapter of your semiconductors. Very good. Excellent. Let's move to the next question. For a polar molecule, which of the following statement is true? Center of gravity of electron, proton coincide, polar. Center of gravity do not coincide, charge distribution is symmetrical, dipole moment is always zero. For polar molecule, the positivity and negativity will be separate, and that is why there will be a dipole moment. That is why there will be a dipole moment. Remember that. So the positivity and the negativity do not coincide. They should not coincide. Option B. Okay, perfect. Awesome. Tomorrow session timing will be again in the evening only, man. Yeah, in the evening, because during the daytime generally people are studying, and in the evening what happens is your nervousness, restlessness builds up and you do not study so much. So I thought evening time is the best time. Morning time you are more systematic planned, you have that enthu, and that enthu dies off by the time you come back in the evening, right? Am I right or no? So that's why I'm here for the evening. When a comb rubbed with dry hair attracts pieces of paper, this is because comb polarizes the paper. Comb induces a net dipole moment opposite to the field. Electric dipole, no, electric field due to the comb is uniform. Comb induces net dipole moment perpendicular. What nonsense all this. Comb polarizes the piece of paper. So this is your comb, for example. Okay, this is your piece of paper. What will happen? One will become positive, one will be negative. Let's say the comb is negatively charged. Okay, example. So the negative will attract that positive, positive will attract that negative. So that attraction comes because of this. Is that right? Yeah. So it is basically option A. It polarizes it, and that's the reason why it gets attracted to it. Polarization causes that attraction. Very good, very good, very good, very good. Moving on to question number 4, guys, passage 4. We are going to do 10 passages today, and I have kept extra 2 passages as homework. Okay, so 10 passages or 10 case studies, you can say, for today, and 2 passages or 2 case studies as homework. You'll be getting the PDF in the description box. The link will be there below. Okay, so you can download it later on. So don't worry, it's not going to be a very long session. It's going to be a quick session only, because I know you guys are more in need of content than time. All right. Neutrons and protons are identical particles in the sense that masses are nearly the same, but there is a new force, which is the nuclear force, does into distinguish them. Meaning particles are like, but the nuclear force, doesn't to distinguish them. Doesn't distinguish, and the force called nuclear doesn't, I think the wording is wrong. Nuclear force is the strongest force. Stability of the nucleus is determined by the neutron proton ratio, mass defect, or packing fraction. Shape is calculated by quadrupole moment, and spin of the nucleus depends on even and odd mass number. Volume of the nucleus depends on the mass number. Whole mass of the atom is centered around the nucleus. Basically the entire theory of nucleus from modern physics is there over here. Okay, so let's have a look at the questions, because the theory looked very difficult or crazy, some quadruple dipole moment and all of that, but none of that will matter so much once you look at the questions. The correct statement about the nuclear force: charge independent, short range, non-conservative, all of this. So most of the answer is not there in the passage, by the way. You should recollect from NCERT and common sense what were the characteristics of a nuclear force. The nuclear force depends on the spin. It does not depend on the mass or the charge. So, charge independent. This force is extremely short ranged in the term like femtometers. Anything above 10 raised to negative 15 meters, the nuclear force falls drastically. So it is very short range. In fact, it is the strongest force, and that's why it is a very short range force. It is non-conservative force. It does not follow Coulomb's law or inverse square law or gravitational law kind of forces equation. It is a very different kind of force. So it is non-conservative in nature. That means mechanical energy will not be conserved when these forces come into play. So in fact, all of this should be the correct answer. Okay. Yeah, right, right. Very good, very good, very good. Let's go to the next question. Tomorrow I'll be doing complete revision, and in that complete revision, there will be a mix of MCQs, mix of 1 marker, 2 marker, all those higher marker questions, a mix, and we'll be going chapter wise. So all the chapters of your book 1 will be covered tomorrow. Okay. Then book 2 will do day after tomorrow. Okay. So that is the plan. Okay, let's go. Let's go. The range of nuclear force is of the order of, just I told you right now, just now only I told you. Yeah, what is that? 10 raised to negative 15 meters. It's a femtometer. So this is basically a femtometer, FM. That F over here stands for negative 15 power of 10. Negative 15 power of 10. Yes, option D is the right answer. Very good. Edito, Lakshan, Rajendra, HYT Gaming. Amazing, man. Amazing. Moving on to the next one. A force between two protons is same as a force between proton and a neutron. The nature of the force is. So the force between two protons, yes, it can be electrostatic, but it is also similar as the force between a proton and a neutron. So it can't be electrostatic because proton is positive, neutron is neutral. So it has to be, it can't be gravitation because gravitation will be different. So yes, it has to be your nuclear force, but that too strong nuclear force, because proton repulsion, proton neutron attraction, yeah, that is countered by the strong nuclear force which comes inside the nucleus. Yes, option D, perfect. Moving on to the next one. Come on, my dear warriors. Very good, Mohan. Gungun, Nega, only cricket. Amazing, amazing, man. Amazing. Come on, figure out the next question. Coming up on your screen. Coming up on your screen. Yes, what is it? Okay, where do these questions come from? These questions are coming from the board, man, like the digital board. Yeah, it comes from that. So it comes from my laptop to this via the internet. Two protons are kept at a separation of 40 Armstrong. Fn is the nuclear force, Fe is the electrostatic force between them. Then, now 40 Armstrong, guys, this is quite a distance considering the nuclear distance, because Armstrong is 10 to the power negative 10. It's much larger than 10 to the power negative 15. So at such a range, nuclear force will become very weak. Electric forces become dominating in nature. So nuclear force is much weaker than the electrical force, which means option A is the right answer. Okay, perfect. Thank God you guys understood the joke. I thought people will be like, sir, what are you saying, sir? He did not mean like that. I also know, man, what he meant, what you meant in that question. Okay, we should all have fun. Very good. All the nucleons in an atom are held by, all the nucleons in the atom are held by nuclear van der Waal, tensor, Coulomb. Who are these people, man? Why did these people come out of nowhere? Nuclear only, no? Nucleus, nucleon, nuclear. Why will van der Waal come and do all this nonsense? Why will tensor force, Coulomb force? No. Coulomb force is in fact acting against it. It will try to destabilize the nucleus. Keep that in mind. Okay. Perfect. Let's go. Yes, option A. Moving coil galvanometer, fifth passage, fifth case study on your screen right now. Yeah. CBSE leaks. Wow. Who are these people? I know there are channels. We leaked the paper, but title will be also like that. CBSE leaked the paper. I saw some state board uh, channels, doing these kind of sessions, not in Vedantu, somewhere else. And people are paying money, 500 rupees, 1000 rupees. And every year they come, they get thousands of views and thousands of idiots who pay for those leaked papers, and they disappear for the next year and again they come after 1 year. Man, really, you guys are geniuses to believe into such things. So, CBSE leaks can't happen. First of all, multiple sets. Second of all, very secure. CBSE is a pro, man. NTA is learning from CBSE. Understand that CBSE has been conducting national level examination, board exam. That is not ABCD option. That is proper correcting you have to do. That level of examination from long time. So CBSE is like the godfather. Okay, so leaks, forget it. Don't waste your time. Hmm. So focus. So standard moving coil galvanometer based question. Okay, this theory is exactly as it is in NCERT, nothing new, right? Yeah. All right. So let's then look at the questions then. Okay. I hope you read the theory page right over here. It's the same as in NCERT. You might actually need more knowledge than what is there in your passage because you might need to recollect the formulas maybe. A moving coil galvanometer is an instrument which is used to measure EMF, potential difference, resistance, is a deflection instrument which gives reflection when a current flows through its coil. This is very important. See, moving coil galvanometer can be used in a special case as a ammeter or a voltmeter or to measure even resistance. Okay, like in a you can say meter bridge and all of that. But that is an indirect application. But what does it actually end up measuring? It always measures current by small current passing through it. So it's option D, guys. Yes, very good. Yes, it can be used as a voltmeter. It can be used to measure EMF, everything. But that is secondary. That comes from the primary concept of measuring current, not anything else. Okay. So it's a basically current measuring device. Keep that in mind. Okay. Next question. To make the field radial in a moving coil galvanometer, number of turns, magnet is horseshoe, poles are of very strong magnets, poles are cylindrically cut. This is a very good concept, guys. You will see that the poles are basically cylindrically cut, something like this. And because of that, what happens is, let's say this is North Pole, this is the South Pole. So the magnetic field goes like this. The magnetic field will go like this. Can you see what has just happened? This is like a radial field. Yeah, this was your, for example, South Pole. This was, let's say, your North Pole. Magnetic field lines are going like this from North Pole to South Pole. These are cylindrically cut. It feels like the field is radial. Radial means symmetrically distributed about the center in all the directions. So poles are cylindrically cut. Option D is absolutely the right answer. Yeah, yeah. Rajkumar, where is Gopika ma'am? Like, you want me to give her address? I can't do that, man. Sorry, that's not right to ask teacher's address. Gopika ma'am is at her home or sometimes she visits office. Yeah. So sorry, man, I can't give Gopika ma'am's home address like that. Hmm. All right. Next question. The deflection in a moving coil galvanometer is directly proportional to torsional constant, directly proportional to the number of turns, inversely proportional to the area of the coil, inversely proportional to the current. My God, all these things. The deflection in a moving coil galvanometer. Well. Theta is equal to basketball. Just like for football, you have FIFA. For cricket, you have IPL. For basketball, you have NBA. So NBA. And when you play basketball, you never kick the ball. And kicking is down from below. That means in the denominator. K for kick. Okay. And this is correct. So that is how I remember the formula. So now from this, it is very evident what should be the right answer. Come on, guys. Yeah. Option directly proportional to the number of turns. Theta is directly proportional to the number of turns. Option B. All other options are incorrect. Very easy way to remember the formula. Option B. Yes, perfect. In a moving coil galvanometer, turns, area, current, field, the torque is M magnetic moment cross B. Magnetic moment is National Investigation Agency multiplied by B. NIAB. NAB. Yes. NIE, whatever you want to call it. Yes, option D is the right answer. Perfecto. 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 Amazing. Amazing. Let's go to the next one. To increase the current sensitivity, we should do what? Well. Theta is equal to NBA basketball. Never kick the basketball into current. So current, if I take this term is called current sensitivity. How much deflection you show per unit ampere of current. So what do I do? Strengthen the magnet, torsional constant of the spring. We should decrease. Oh, question is what should we decrease? Obviously, you should decrease this. You should decrease this so that this quantity increases. So torsional constant is the right answer. Option B. No, not area of the coil, man. It is option B, bro. Option B. Okay. Is it absolutely clear, everyone? Very good, very good, very good, very good. Amazing. Let's move to the next case study, number 6. According to wave theory, light of any frequency can emit electrons from metallic surface provided by the intensity of light will be sufficient to provide necessary energy for emission of electrons. But according to experimental observations, light of frequency less than threshold frequency cannot emit electrons, whatever the intensity of incident light. Einstein also proposed. Oh, Einstein proposed. Oh, I was thinking Einstein proposed to some girl because Valentine's Day was near. I was thinking about that. That electromagnetic, oh my God. So Einstein proposed to electromagnetic radiation that you are quantized. Very, very nerdy Valentine Day, I feel. He's proposing to electromagnetic radiations. Okay. So we have wavelength 1, 550 nanometer incident. The stopping potential is 0.19 volt. Suppose the radiation is 190 nanometer, then okay, maybe some questions might be there later on. So guys, this is basically photoelectric effect. Don't waste your time so much on this. So whenever you realize direct concepts from NCERT are there, chumma they play around, waste your time. Don't get scared. Directly move on to questions and then come back. Okay. Most of the times kids will be doing that only. Photoelectric effect supports quantum nature of light because photoelectric effect supports quantum nature, not wave theory. Wave means continuous. Continuously it should come. Quantum means in packets, in quanta. Okay. There is a minimum frequency of light below which no photoelectrons are emitted. Yes, it does tell me about it. Maximum energy depends only on the frequency and not intensity. Correct. Remember photoelectric equation. The maximum kinetic energy depends on the light's frequency. Okay. Not on how much intensity it is. Even when metal is faintly illuminated, that means even when few photons are falling, but those photons are highly energetic, then the electrons will be emitted and that happens instantaneously. It's not like it waits. Oh, very few photons are there. I will wait for more photons to fall. Then I will emit. No, it is an instant phenomena. Electric charge of the photoelectrons is quantized. No, electric charge of the photoelectron is quantized is not because of quantum nature of, or it does not support this particular thing. Yes, it should be A, B and C, which is option A. Yeah, perfecto, perfecto. Sir, will you be my Valentine? Man, what happened, man? Why are you so late? This is so sad. It's already over, no? Today is what? 17, no? Aren't you ashamed? You are asking me for Valentine on 17? You should ask me before. What is this? What kind of behavior is this? Very bad, guys. No, you're late. Or maybe too early for next year. In a photoelectric effect, electrons are ejected from metals. In the incident light has a certain minimum. In photoelectric effect, electrons are ejected from the metals. If the incident light has what? Minimum wavelength, minimum frequency, amplitude, angle. Bro, simple, frequency. If your frequency is more than the threshold, then photoelectric effect will occur. But if your wavelength is below threshold, then also photoelectric effect will occur. So frequency is inversely related to wavelength. Keep that in mind. So frequency should be more than the cutoff. Wavelength should be less than the cutoff. Make sense? So answer is frequency. Perfecto. 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 Minimum frequency. Amazing. 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 Let's go to the next question on your screen. Calculate the stopping potential of the surface. Ayyo. Let us go back. What equation will we use? Where did it go? Where did it go? So 550, 0.19, 190, what it is? 550.19, lambda 1, 550 nanometer stopping potential 0.19 volt, lambda to 190 nanometer. What is the stopping potential? So the photoelectric equation is Hc by lambda is work function plus E into stopping potential. So if I do it two times, and if you want, you can also put this as 1240. This will be in electron volt, and wavelength in, let's say, nanometers. Wavelength in, let's say, nanometers is work function in electron volt plus E times of stopping voltage. So then things become little bit on the easier side. So when I write 1240 electron volt divided by wavelength 550 is a work function plus E multiplied by 0.19. Similarly, what is it? 1240 divided by wavelength 190 electron volt is work function plus E multiplied by stopping voltage. It's quite obvious now. You just have to subtract these two. That's all. So 1240 common 1 by 550 minus 1 by 190 is equal to, this is electron volt, is equal to 5 will cancel, E times of 0.19 minus V2. E will cancel. So basically my V2 will be 0.19 minus 1240 multiplied by this thing. 1 by this minus 1 by this. So subtract everything and you will get the correct answer. Okay, do that. All right. Perfecto. Perfecto. Yeah, very nice. The answer comes out to be how much? 4.47 volts. 4.47 volts. Very good. Okay, amazing. Very good. Oh, welcome. Gopika ma'am's army is also here. Amazing, amazing. All the Tamil students, welcome aboard. I know you are in need of neat English channels and you are coming here to JEE English. I saw all your comments. NEET students, PCB students, mocking JEE students. Sir, I'm PCB student, NEET student. I got 98 percentile. Sir, I got 99 percentile. Sir, I got 90 percentile. PCB, think about it. That student skipped math section, only physics, chemistry wrote and getting 90, 98, 99 percentile. Okay, kudos. Very good, guys. Shows your dedication. And it's like a mock test for all of you for NEET. And yeah, it should also pinch my JEE students that come on, PCB students getting PCM better marks than PCM means we are only taking things lightly. We have to work hard. So just with physics, chemistry, students are able to do it. So with maths, how much more should you be doing it? So guys, work really hard for the April attempt. Okay. All right. Let's move on to the next one on your screen. Calculate the work function of the surface. Well. Same thing, guys. So 1240 electron volt divided by what was that wavelength? It was 550, right? So 550 is equal to work function in electron volt plus E multiplied by 0.19. Solve this, you will get the value of 5. It will be 1240 by 550 minus 0.19. Whatever is E will be in common. So you will get the value of the work function, which comes out as 2.07. Which comes out as 2.07 electron volt. 2.07 electron volt. Sir, I solved 5 year sample papers. Yes, of course, man. Sample papers are very important. It's not like exact same question will come, but definitely it will give you an idea of what kind of questions will come. CBSE physics has been, quite intimidating in certain sets. Last year also one set was very difficult. Students came crying out of the exam hall. Usually it doesn't happen for board exams, but it happened last year, and even before that particular set became very hard. So I don't know who that unlucky person will be. Okay. So better go with all the previous year papers, right? Oh. So calculate the threshold frequency. If you know work function, threshold frequency easily you can get. So work function, we just got it as 2.07 electron volt. So 2.07 electron volt, meaning 1.6 into 10 to the power minus 19 is 6.6 into 10 to the power minus 34 multiplied by threshold frequency. Solve that, you will get the threshold frequency as 500 into 10 to the power 12. Okay, so you should get this as 500 into 10 to the power 12, which is over here as option A. Okay, simple. This was in electron volt, so multiply it with the value of E, which is 1.6, to get it in SI units, because Hertz is a SI unit. So you need to do that conversion factor. Okay, all right. Yes, man, class 11th lectures will start immediately after the physics examination. Okay. Case study number 7. A and B went to purchase a ticket of a music program, but unfortunately, one ticket was left. Guys, this is out of syllabus. Okay, but not entirely, partly. So this scenario is out of the syllabus, but concept is there within the syllabus itself. I think most likely diffraction. They purchased a single ticket and decided A will be in the hall during the first half and B during the second half. Both of them reached the hall together. A entered the hall and found that the seat was behind a pillar which was creating an obstacle. He was disappointed. He thought that he would not be able to hear the program properly. So, see, these are basically cheap fellows. Cheap fellas. What did they do? They bought only one ticket. And these two, Andu Pandu, what they said, Andu, listen, you go into the movie theater first half. Okay, I will go in the second half. What logic, bro? Amazing, brilliant. Claps. I'm clapping. No sound is coming. It's miraculous. What kind of planning you guys did? And see his luck also. When they enter the hall and sit in that seat is behind some column, some obstacle. So what is he going to hear? That's what he thinks. B is waiting outside the door, because first half A will go, second half B will go. So B is right now waiting outside the door, and the door is not fully closed. What fellows? There is a little opening, but surprisingly, A could hear the music program. This happened due to diffraction of sound. The fact that we hear sounds around corners and around barriers involve both diffraction and reflection of sound. Diffraction in such cases helping the sound bend around the obstacles. In fact, diffraction is more pronounced with longer wavelengths, implies we can hear low frequencies around obstacles better than higher frequencies. Performer, pillar, this idiotic friend, the sound is bending around that corner, that is diffraction. And there is this other friend outside the door, there is a small opening. So whenever any kind of wave hits an obstacle or goes through an opening, it spreads. That spreading is called diffraction. You have studied diffraction in light, but diffraction in sound is also possible. Diffraction in sound is not in syllabus, but it's there as a case study. Okay. So he could also hear the program, but he noticed that when the door opening is less, he could hear the program even being little away from the door. This is because when the width of the opening is larger, then the wavelength of the light passing wavelength of the wave passing through the gap, it does not spread out much on the other side. But when the opening is smaller, then the wavelength is more diffracted and spreads greatly with semicircular wavefront. The opening in this case functions as a localizing source of a sound. So when the door opening is large, then the sound does not spread too much. But when the door is closed almost and very small opening is there, then the sound spreads better. So that means the opening should be small, the wavelength should be larger for the diffraction to happen, and that opening behaves like a source of sound, a new source of sound, like a secondary wavefront, secondary source. Okay, that is the whole passage. Let's have a look. A and B. Yes, come on, my dear warriors. Focus, focus, focus. Could you hear the music program due to the phenomenon named Ayo, what you are asking, man? Diffraction, no? What else? Whole passage was about diffraction. Diffraction is the bending of wave, be it light or sound, doesn't matter, around an obstacle or through a aperture or through a opening or a slit. So that is obviously diffraction. Diffraction is more pronounced with which wavelengths? Just now only I told you. Long, short, fluctuating and all. Ayo, come on. Tell me, guys. What is the correct answer for this? Everyone. Come on, spam the correct answer. I want to see how many of you are attentive. No need to go back and check the passage. Be attentive, be focused. Shows how focused you are. Oh, Anant, nice to see your profile picture, man. This profile picture we had designed long time back in the day during COVID times for all our students to put up as a display picture, and you still have it. Shows that maybe you are our V Enthuse student. Our initial channel name was V Enthuse, and then we made it more general and called it just Vedantu J English. So looks like a long-term student. Yes, option A, longer. Very nice. So longer wavelength, shorter hole or shorter opening, smaller opening is better for more spreading of that wave. The minimum and maximum frequencies are 550 and 10, 550 kilohertz, I believe, because options also has kilohertz. Which frequency is better audible around the pillar? So basically, better audible means wavelength should be more. That means frequency should be less. Frequency less means 10 kilohertz. So option A should be the right answer. Yes, absolutely the correct one. Option A. Very good, Praga. Sanjit, amazing, 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 amazing. Moving on to the next one. Diffraction of sound takes place more when sound is diffracted through an opening having width equal to the wavelength. Sound is diffracted to opening having width more than the wavelength. Sound is diffracted to opening having width less than the wavelength of the sound. Yes, it definitely should be less than the wavelength of the sound. Yeah, the opening should be smaller, wavelength should be bigger for the diffraction, for the spreading to happen. So option C will be absolutely the right answer. Correct? Very good. Moving on. How the waveform will look outside the door of the hall. Outside the door of the hall, well, if this is the door, then the wavefronts, because the sound will spread, it will go, it will go in a localized sound source. I think that phrase is also there. Localized. Localized means at a very small place, there is a source placed. If it is non-localized, that means the source of the sound is spread everywhere. It feels as if there is a concentrated sound source at that opening. Yeah, option C is absolutely the right answer. Very, very good. Moving on to the next passage or case study on your screen. Resonance. Okay, LCR circuit. LCR is given and it's a standard LCR passage, guys. There is nothing great about it. Just have a look at it. I'll give you 20 seconds to read the passage quickly. C for Captain Shreyas. Yes, absolutely right. Okay, come on. Read the passage quickly. We'll start with the questions. Okay, ready? Okay, done. Standard passage. Nothing great. Amazing. Let's start. Find the value of the source for which current amplitude is maximum. Current amplitude is maximum means resonance. And resonance happens when omega is 1 by root LC. That's it. So substitute the values, you'll get the answer. L and C both are given. 0.12 and 480 nanofarad. 0.12 and 480 nano. Nano means 10 to the power negative 9. So do the maths and calculate it. You should get the answer as I think 663.48. Okay, so 663. Okay, hertz will be, sorry, not hertz. Oh, this is frequency they have asked. So what we need to do is this will be nothing but 2 pi into f. So if you want to find frequency, whatever 2 pi value is there, you have to put it on that side and then only we'll get it in hertz. Okay, frequency is not the same as omega. Omega is angular frequency, f is your regular frequency, which is 1 by time period. So omega is 2 pi, just use it and you'll get the answer. Moving on, what is the value of maximum current? So when we talk about maximum current, well, I know the current will be nothing but Vrms divided by Z, but during resonance, the impedance is the resistance. What is the voltage? Well, let's check it out. 230. What is the resistance? 23. Okay, so this is 230 volts. This is 23. So 10 amperes is the maximum RMS current, but none of it is there in the answer because maximum current they have asked. So I naught is IRMS and this is by root 2. So I naught will be IRMS, which is 10 multiplied by root 2, which is 10 multiplied by 1.41, which is 14.1 ampere, which is right over here. Option A, guys. Option A is the right answer. Okay, they have asked the maximum peak current amplitude, you can think of it. Yeah, correct. Very good, very good, very good. Let's move on to the next question. What is the value of the maximum power? Well, if you know maximum current, you also know the maximum power also. So power is nothing but Vrms square divided by R. That's it. Vrms is 230. So 230 square divided by 23, guys. So that will be 23 multiplied by 23 multiplied by 100 divided by 23. Yes. So that will be nothing but 123 will cancel. So 2300 watts. 2300 watts, 2300 watts. Why have they given like this? This is option, closest option is B, I think. Yeah, option B is the right answer. Yeah, the correct answer is actually 2300, but yeah, 2299.3. I don't know why the examiner told it. Yeah. How to find if it is IMAX or IRMS? If they just tell what is the, yeah, actually you have a point over there. What is the value of the maximum current can mean both the things, whether it is actually the amplitude of the current or whether it is the maximum RMS current. So, it can be confusing. So, look at the options. So, if the options are not matching, then they have asked the other thing. Okay. But if it is a subjective question, then I would suggest put both the answers, because that statement can be very misleading, because the current graph increases and then decreases. The maximum RMS current is a different thing. Whereas when the current is maximum, RMS current is maximum, at that moment, what is that peak current in that sinusoidal graph? That is a different thing. So, ideal statement would be the peak current. Peak maximum current means the amplitude, which we have calculated 14.4. If it is just maximum value of the current in the circuit, it should be just RMS. So even when I calculated RMS first, but the moment I saw the options, RMS was not there. So that's why I went for the peak value. Okay, simple and sweet answer, guys. All right. What is the Q factor for the given circuit? Q factor, guys, is nothing but your resonant frequency divided by delta omega, or basically we can say 1 by R root of L by C. Everything is given. The resistance is 23, inductance, capacitance, everything is given. Just substitute literally everything and get the answer. Inductance 0.12, 480 is capacitance. 0.12, this is 480 nano, 10 to the power minus 9. Yeah, solve this, you should get the answer as 21.74. This is 21.74. That is the quality factor. Okay, what is this? This is your resonant frequency. Resonant frequency, remember, and this is called as the bandwidth. This is called as the bandwidth. Just remember this. Okay, perfect. Okay, let's move to the next one. At resonance, which of the following is maximum impedance current? Both, neither. At resonance, it is the current which is maximum, impedance is minimum. So option B is the right answer. Least impedance, in fact, the impedance becomes the resistance at resonance. So least resistance happens at resonance. Maximum power factor becomes 1. That is the whole concept of it. Cool. Shall we go ahead then to the next one? Yeah. Self-induction. Remember, self-induction is when current flows, the flux is linked with it, and the flux is related to the current by this number called as self-inductance, L, which is measured in Henry. Any current which flows will induce an EMF in the coil. The self-induced EMF of a coil is set up when current passing through it changes at some rate. It is the measure of the opposition to the growth or the decay of the current. Also, the value of inductance depends on the number of turns, area, and permeability. Standard definitions of impedance and self-induction. Okay. So, do we have to find the square root of that specific value? Yes. 1 by root LC and 1 by R. Definitely, you have to find that out, Fatima. Yeah, I know it is deleted, but you might get it as a passage case study where the formula is mentioned. Okay, so the formula can be mentioned in the passage. In this passage, it was not mentioned, but if that question comes, don't be scared. Okay, I know otherwise in NCRT quality factor has been deleted now. Okay, come on, my dear warriors. Figure out the first answer. The inductance in a coil plays the same role. Inductance, what does inductor do? If current is flowing, it doesn't do anything. If current changes, then it opposes that change. It is like an inertia. It's like a moving body will continue moving. But when it tries to change its state of rest, that's when you feel the inertia of the body, resistance to change the state of motion. So it feels like inertia in mechanics, which is option A. Okay, so current is flowing, no problem. It will not affect it. Inductor will not even bother. Steady current, inductor will behave like a wire. The moment current increases, it opposes. Current decreases, that also it doesn't like. It will oppose that change. Option A. Very good. Let's move to the next question, guys, on your screen. Now, current flowing, inductance, magnetic flux is how much? Flux is Li. Inductance is 5, current is 2.5, 2.5 is 5 by 2, 5 5 is 25, 25 by 2 is 12.5. Flux is measured in Weber. So 12.5 Weber, which is option B, is the right answer, my dear warriors. Yes, straight, simple, very nice, very nice. Moving on to the next question on your screen. Inductance depends on. Now I know in the passage they mentioned the dependencies, but it didn't mention the formula. So now your knowledge of NCRT or your theory knowledge comes into play. Inductance is given by mu naught n square area into the length of the solenoid. So radius, area is nothing but pi r square. So clearly inductance is proportional to the square of the radius. L is proportional to square of the radius, which is r square right over here. Okay. So you should know the formula. Mu naught n square. What is that small n? This is number of turns per unit length. So number of windings which are there in that solenoid per unit length. Keep that in mind. Moving on to the next one. What is the unit of self-inductance? We all know phi is Li. So L will be phi by I. Phi is measured as Weber. Current is measured as ampere. So a Henry is when a flux of 1 Weber is produced per unit ampere. So Weber per ampere. Weber per ampere, guys. So yes. But Weber per ampere is not there over here. My bad. So we need to think about some other unit then. Weber per uh, ampere. So what do I do? What do I do? I know there is one thing called as time constant, and that time constant. Yeah, how many of you remember, guys? Time constant is nothing but L by R. L by R. It's a deleted syllabus, but if you know that, it helps you in this question. So from this, L will be time constant by into resistance. So time constant is second and resistance is ohm. So ohm second will be the right answer. This was actually Weber inverse ampere. So this is not Weber per ampere. So this option B will not be right because that is exactly opposite of it. It is 1 by Henry. So option C is the right answer. How many of you remember this or have studied it? If you don't know time constant, just have a look at it. You will probably understand it in very simple ways. Okay, growth and decay of current in LR circuits. It's there for JEE Advanced, but not for mains. So maybe you might have studied it for JEE Advanced. So such things can also come. So very tricky question if you think about it. Induced EMF in a coil of 10 Henry inductance in which current varies from 9 to 4 in zero point 0.2 seconds is how much? Now there is a formula for it. E is equal to L delta I by delta T. Inductance is 10. The change in the current is 9 to 4 and in zero point 0.2 seconds. So 10 multiplied by 9 minus 4 is 5 divided by 0.2. Okay, 0.2 is 1 by 5. So 10 multiplied by 5 multiplied by 5, 25. So 250 volts. So 250 volts is option B, should be the right answer, guys. Perfect. Very good. Hi, sir. I'm from Sigma Batch. Thank you for your efforts. I was able to score 98.93 percentile, Captain 21 pilot. Oh my God. I'm so pleased and so happy, man. And now, without even thinking, just prepare for J Advance and boards. So I'm pretty sure you will do well. Just get 75% and above, because at the end of the day, your IIT JEE rank will decide your college. And all the best, man. I'm super duper excited to hear your IIT JEE rank in June, right? Once the J Advance results will come. I'm pretty sure you are going to an IIT now. Just prepare very well. Don't lose focus. Focus on J Advance now. Okay? It's a very good percentile, and I'm so glad our Sigma students are doing so well. Already I've seen a lot of students putting up on the groups and tagging and messaging everywhere. Yeah, some students are also disappointed because, sir, I missed by one mark or one percentile or this percentile, sir, my target was 96, I got 94. So yes, there are all kinds of stories, but I'm very happy that kids have done well. And I know that, as a matter of fact, had they not been a part of Sigma batch, they would have done much worse. So whatever they have scored has been for their better, and they have used their abilities, or maybe they have not completely devoted themselves at times, because of which you have not achieved your scores. So now is the time to regroup, reassess, re-strategize, and focus on the April attempt in case you are not satisfied with your January attempt. But if you are getting good scores, just go with J Advance, man, because IIT is waiting for you. Okay, let's go to the last passage, and after this, two homework questions I'll be giving it to you in the PDF, and the description box will contain that link. Electric field strength is proportional to the density of lines of force. Electric field strength at a point is proportional to the number of lines of force cutting the unit area placed normal to the field at that point. Illustration is given. So if the field lines are closer, so more lines will be passing through or cutting through that area. It is strong electric field. If it is far away, then it is a weak electric field, standard concept. All right. Yes, one more case to go, man. Yeah, gone case only now after this. Sir, I got 88 percentile. Can I get 95 in April attempt? Yes, definitely. Who is it? Granula to goated. Of course, man. 95 is not even a big target, man. Aim little bit higher. Aim like 98, 99. And you might be thinking, sir, from 88, 99, is it possible? I'm telling you, 3 years back, I remember this because I conducted the interview also. This girl did not even qualify JEE mains for advanced in the first attempt. I mean, very bad percentile, like 80s, not very bad, but 80 percentile. Uh, the relatives mocked, but then she struggled. She fought for it, and in the April attempt, she got around 94 percentile or 93 percentile. That time, this was 3 years back, I think. So that time, barely just qualified from mains to advance, but she didn't give up. She prepared for JEE Advance in those last 2 months, and then got a rank also. Not a great rank. It's not like all India rank 10 or 100, but maybe some 3, 4,000 or 5,000 rank like that. So got into IIT. So there are students who slowly go up, just at the borderline, they just pass themselves, push themselves, and somehow get into IIT. So you can be one such example this year, right? So if you got 89, 88, I really feel that there is a good chance, in fact, a great chance for you guys to get into IIT. Okay, do not lose hope. April is there and time is there. Just have to struggle, have to work hard. If you are ready to struggle, everything will happen. Don't take it lightly. Yeah. Electrical lines of force about a positive charge are radially outwards, obviously. Option A, isn't it right? Okay. If you got 75 percentile, getting 95 is not a difficult thing, man. 95 is easily possible. I'll make a strategy video for that. maybe after the physics exam. I don't want you to lose focus. Which of the following is false for electric line of force? They always start from positive. False, false. Okay. Question is about false. Read it. They always start from positive and terminate on negative. This is correct. They are always perpendicular to the surface of charge conductor. This is correct. They are always closed loops. Wrong. They are parallel and equally spaced in uniform electric field. Correct. So option C is the incorrect. They do not form closed loops. Okay. Meaning like this is not allowed. This is not allowed for the electric fields which are generated from a static charge. That is okay for a magnetic field. Let's go to the next one. Which of the following patterns is not possible? I think this is obvious. This is uniform field. This is point charge radial field. This is also like possible from a point charge. This is cyclic closed loop. So option C is not possible. Okay. Option C is closed loop, which is definitely not possible. Cool. Let's go to the next one. Electric field lines are curved in the field of a single positive or negative charge, in the field of two equal and opposite charge, in the field of two like charges, both B and C. The field of a single, no, for a single positive or negative charge, what will happen? The field lines are not curved, they are straight. But the moment one positive and negative is there, it is curved, or even two positives are there, then also it curves. Then also it curves, right? So B and C, option D. Yes, correct answer is D option. Both B and C are the right answers. Yes, not just B or C, both of them are right. In this diagram, shows the electric field lines due to positive charges. The magnitudes EA, EB and EC at the points A, B, C are how much? A, B and C. Come on, let's see how many of you can get this. Think. See, the magnitude depends on the closeness. Yes, the closeness of the field lines. If you look at A point and B point, the field lines are equally close. So A and B must be equal. But at C, hardly any field lines are there. So the field strength is weak. So A and B are equal and they are stronger than at C. So option C seems to be the right answer. Yes, EA equal to EB more than EC. Perfect. Okay, at this point and this point, number of lines are equal per unit area. So strength is the same. C point, everybody is running away as if the field is very, very low. So definitely makes sense. So option C, guys. So now I have two homework passages. So one passage is right over here. This is question 11. It's based on electric current electricity chapter. There are questions on this. You can download it later on. After the session is over, I will be uploading the PDF. And then this is the second passage on, I think, quantization of charge and friction and all of that, how charging happens. So there are questions based on it. So yeah, these are the two homework questions. Okay, you'll be getting it. All right. So I'm extremely proud once again that we are getting 99.9, 99.99 percentiles literally from every corner of the country. And our students are there literally everywhere. Many of them are our offline students. Many of them are also our online students. Some are, crash course, students. Some are our long-term students. So all kinds of students who were sincere, who are dedicated, following the plan are doing well. And thousands of results are going to slowly come up. Already 50 plus students above 99 percentile till yesterday, and 210 students above 90 percentile. Okay, so this number will increase because yesterday only the results came out and these creatives were made yesterday. So after tonight we'll get a new one for tomorrow. All right, so God bless you all. Take care, have a great time, and yes, download the PDF and do not forget to like this video. Tomorrow we'll have a marathon on 11th standard, sorry, not 11th, 12th standard part 1. Day after tomorrow part 2. Okay, so we'll have those sessions tomorrow and day after. Bye bye, take care.